Okay, please be seated. All right. Let's go back to the apps. Now, right now we already say that we can use histogram to build a model so that we can have an idea about the distribution of eruption time, right? So, and with this model, we can estimate the future events. But actually, a way that is better than histogram is actually a density function. Okay, let's use this checkbox density function. Okay, actually we can uncheck the histogram and check this density function. Okay, right. And again, you can see that this density function is kind of like a continuous density function, right? For those who already have learned about statistics and probability, you should know this idea about PDF, CDF, right? So this is PDF, this is the probability density function, right? Okay. So usually when we are doing business analytics, and in R, it actually have a way to build a distribution function. You just give it a data, and then with a few function code, it will build a density function for you, right? And this density function is different from, it's kind of like quantized histogram. It actually gives you a continuous mathematical function, okay? And usually it is better for us to use it to predict future events, right? Okay, so actually come with this PDF, we can also plot so-called CDF, right? With this, let's see that how many people know what is probability density function? Do you have an idea about what is a probability density function? Okay, so let's see how it works, right? It'll give you an idea about what is a probability density function, right? Suppose that we build a probability density function, okay? And we want to estimate the probability that, suppose we want to predict the eruption time of next eruption time, right? Of next eruption, right? Suppose we want to estimate the period, the time of next eruption, right? And with this density function, we actually can specify a range of time, right? For example, if I want to see the eruption time between 2 minutes and 3 minutes, okay? And we can see that the probability is like 18.4%, right? So the idea of a probability density function is that it's a mathematical function, okay? So that if you can calculate the area under this curve, okay, it's actually the probability that we want to estimate, okay? For example, if I want to estimate the with this density function bandwidth set to 1, and then can you actually like using this slide bar, can you predict the probability that the next occurrence will fall within the range of 2 minutes to 4 minutes? Use this slide bar, right? You can actually estimate, because we already built this density function, right? And I told you that they are. Don't worry about that yet. We will go to that later today. Okay. Actually, nowadays to build a density function is easy, right? If you do not know how to do it, you can go to ChatGPT. You say that I have this data and I want to make a density function in R. It will give you the program already. Okay, so you don't really need to worry about how to build the model, right? It's actually nowadays not a big problem. Okay, the problem is you need to know how to use this model to do a prediction, and how to use this model to do the how to use the prediction to do a business decision, right? That is what we are going to focus on in our course. Okay, so with this slide bar, we can actually kind of like, if I want to know the probability that the next eruption time will fall within 3 minutes and 4 minutes, I can see it here, right? Okay, so can you, by using this slide bar, can you like estimate the probability that next eruption will fall within 2 minutes and 4 minutes? Anyone? Just use the slide bar. You don't need to do anything. Anyone? Everyone is here, right? You have this density function check, okay? And you can adjust the slide bar, right? So you can know the probability of any period, right? So what is the probability? Okay.
36.7%.
Sorry?
36.7.
36.7, right? Because we are talking about like 2 minutes to 4 minutes, right? So it's 36.7, right? How about the probability within 3 minutes and 5 minutes? Actually, you can actually move the slide bar like this, right? How much?
59%.
59%? Yeah, it's 59%, right? So anyone know? So with this model, we can actually give us a precise estimation. Okay? Give us a precise estimation of the event that if the event that fall into this area, then we can use this slide bar to help us calculate the probability, right? Okay. So as I said, usually you don't need to worry about how to build the model. The idea is after building the model, okay, you can use this model to calculate the whatever event that you want to estimate. For example, if I want to like 2.5 to like 4.5, then I would say that you have like 46% of chance the next eruption would have the eruption time fall within this period. Okay? So this is the way to use PDF, right? Don't worry about the mathematics. Okay. So up to this point of time, we already have the ideas about what is the data, and if we put the data into a method, usually it's just a function call, as I told you, right? And we need to set the parameter, as we can see here. For histogram, you actually might need to choose the number of bins. And for density function, you can actually set a bin width, okay. So for example, we set the bin width of 0.5, right? And then you will see that when you change this complexity of the model, the estimation will change, right? So as I told you that the label of detail is not within the scope in our course. So we basically just use the default settings good enough, okay? So once you give the data, this is the basic idea, right? Once you give the data to the method will build a model for you, right? Okay, with the specified complexity, with the specified labels of detail, right? Okay, and the model can have you can actually choose different model. Histogram is a type of model. Density function is another type of model. Don't worry about this mathematical notation yet, right? Okay, you simply have an idea that in the environment of R, if we have gathered the data, we can actually use this data to build a model and use this model to predict the probability of future events for us. Okay, use data and use a method, then we can build model. Okay, and when we have model, we can actually use model to kind of like predict the probability of future events. Okay, let me say it again. We have data, right? In the beginning, we have data, right? And then use this data with a few function code, we can build a model, right? And then with this model, we can predict the probability of future event. Okay? Is any problem up to this point of time? No problem, right? Okay. Actually, there is a video if you would like to learn the detail about how to use CDF and how to use CDF to calculate the probability, right? So you can actually go to this, use control and click. You can go to the YouTube video that tell you the detail about how to use CDF and how to do the calculation. But in our course, we don't have enough time to go through this thing, right? Okay. But basically, for density function, the area that under the curve, right, and within this boundary is the probability, right? Okay. So when you change this, you can see that within the range, I'm using, you can see that here is actually probability is higher, right? And in this range, the probability is actually lower. You see that? Okay? Okay. So later on, we will go to, we'll take a quick look at how to build this model, that type of things. But as I told you, that it's not the important thing that I want to go through. I want to discuss in our course. Okay. Nowadays, you can actually like use ChatGPT and you say that I have this data. Please build a density function for me in R. It will give you the program in like 10 seconds, right? So it's not a big point. The point is, after you have this model, then I want to bring in a business scenario. Okay? That is the point that we want to cover for the rest of today. Okay? Now we already have a model, right? And let's use the density function as our model. and let's set the bandwidth to 0.5. Okay? Set the bandwidth to 0.5. Okay? Right now? Okay? Oh. And then we go to next page. Okay? It's the scenario, right? Now we are doing business. So what kind of business will have the need to estimate the eruption time? What kind of business? For example, if you were a tourist helicopter company in Yellowstone, you tourist helicopter, right? It's a rental company in the Yellowstone. That makes sense, right? If you want to like guarantee that your tourists that every flight you will see a entire eruption, right? Then you need to like kind of have some prediction about the prediction time, isn't it? Right? So let's make it simple, right? Let's make our business scenario like this, right? So it's important for you to predict the eruption time for the next eruption, right? And if your business could be simplified, we simplify our business scenario as a simple game, right? Okay, so in which that you bet $30 on a consecutive period of 60 seconds, right? You actually set a period of 60 seconds, right? For example, from 2.7 minutes to 3.7 minutes, okay? 2.7 to 3.7, okay? This is the 60-second, right? Period, right? So you can choose a 60-second, a 1 minute period, okay? Sorry, when that come out, I cannot do anything. It's really troublesome. So, see, you can bet $30 on a consecutive period of 60 seconds, and you will win $100 if the next eruption time fall within the period you choose. Okay? You can choose a period of 30 seconds. Okay? And then if the next eruption time fall within the period you choose, you will win $100. Okay? We simplify our business scenario, right? Just to tie our business to some uncertainty event, right? So you will have a cost of $30 if you want to do this business, okay? And if your prediction is good, then you will win $100. Of course, you need to deduct the $30 cost, right? So you will have a net profit of $70 if the next eruption fall within the range, okay, of your choice, okay? And if not, you will lose $30, right? Okay? So here's the simplified business scenario, right? I simply want to tie your business scenario with uncertain event. And we already have a model to estimate the probability, right? Isn't it? Okay? So I want you to set the bandwidth to okay? Set the bandwidth to 0.5, okay? Set the bandwidth to 0.5 and use the density function to like estimate your probability. Now use this tool, right? You don't need to write any program, just simply use this tool, right? Set the bandwidth to 0.5. I want you to want every group, right? You can do some discussion. You want to make a decision of whether you want to join the game or not, right? If you do not join the game, you will have no profit and no loss. Okay. If you join the game, you have the chance to like win $100, right? And deducting the cost, you will have a net profit of 70. Okay. And you also have chance to lose the $30, of course. Okay, and get nothing. Depend on the period that you choose, right? So the first question is whether you want to join the game or not. The second question is if you join the game, which is the time period you want to choose. Okay, and the third question is with the period you choose, what is the expected value of the game, right? If you want to join, what is the net expected return of the game? Okay? Is the question clear? Any question? Now I'll give you some time to discuss. Okay? Within the group, use the tool, right? You don't need to write program, right? You already have a model, right? Like use the density function of bandwidth set to 0.5, and you can adjust the sliding bar, okay, to see the probability of every 60 seconds of every minute, okay. So you can move the sliding bar like this, right? Okay. So try to answer these three questions. Okay? How many time do you need? Okay, I'll give you like 5 minutes, right? Should not be too difficult, right? Should not be too difficult. Because you can choose the period, right? So you want to choose a period that the probability is very high, right? It's the highest probability period, right? And then you can, as long as you can choose the highest probability period, you can answer the question very easily, right? Isn't it? And how to choose the period with the largest probability? Well, you simply set it to 1 minute, and you can use the sliding bar to find which period has the highest probability. Apparently it's here or here, right? Okay. And then you can calculate the expected value when you join the game, right? The expected net profit, okay? Net profit, let me emphasize.
What the heck? Cost of goods sold. This is the company. What are you doing now?
Okay, ready yet?
What is this?
You ready yet? Okay.
Cost of goods sold.
So, which team already have answered? Okay. You already have answered?
Sort of.
Okay. How about this team?
But they don't.
You have an answer yet? If you need more time, raise your hand. Okay. Don't be shy, right? Raise your hand if you need more time. So every team have an answer, right? Okay. So let's go to like let's pick a team, right? Like team 1, what is your answer? Yeah. Do you want to join the game?
Yes,
Yes.
we do.
Okay. So when you join the game, what is the period that you choose?
3.9 to 4.9.
3.9 to 4.9.
Yes.
Okay. So if you choose this period, then you will have what is the probability that you will win?
The percentage will be 47.6%.
Yeah, 47.6%, right? Okay. So what is the expected value, net expected value of your?
So because this game we're expected to win $1, right?
Yeah.
And we're putting in $30.
Yeah.
Off profit it will be $70. So after some calculation and with that probability, we're expecting to get $33.32.
Sorry? You have expected value. So the net profit will be $17, right?
70.
Yeah, $17.6 exactly, right? 70? $70? How come it comes with this $70?
But that was before we timed the probability. So after you time the probability, it will be 33.32.
It's kind of weird, right?
Yes, it is. Tricky.
Right? We want to see the expected value, right? Okay. So how to calculate the expected value? It kind of, the reason that you, the way that you calculate the expected value is kind of strange. Anyone have a different answer? Okay, how about this team?
Group 3?
Sorry?
Group 3. Group 3 has an entirely different answer than Group 1.
Okay, so what is your answer?
Now, according, we have the same probability of 47.6%.
Okay, it's the same period, right?
Right, but even so, the winnings, which is $70 and winning.
74 The winning is like
The scenario states that I win $70 net, $70 if I guess correctly, and I lose $30 if I don't. So what we did is we multiply the probability to lose by -30, and then add it with the probability to win, which is 47.6% times net winning 70, and we have a number of 17.6 expected winnings. So we will not join the game.
so you will not join the game?
No, we will not.
You won't.
Because
You won't.
it is simply unfavorable for us.
Okay. Anyone have a different different strategy? See, actually, if we let's do it here, right? Do a new slide, okay? So we know that when we calculate our expected value, right? Okay, you actually have like, sorry. Let me do this. Okay, yeah. So you basically have a chance to win $100, and the chance to win this $100 is how much? How many? 0.476, right? Isn't it? Okay.
Professor?
Yes.
But didn't I?
If you join the game, right?
When I join the game, isn't this scenario stipulates me that I have to pay an entry fee of 30?
Yes. Yes.
So if I win, shouldn't my winnings be $70 instead of 100?
No, if you win, you will win $100, right?
Right,
but you only have 0.476 probability to win this $100.
I understand, Professor, but my point is that the $100 should be deducted by 30.
Yeah, you should be deducted by $30. So after this is the expected value, right? Right? And then you need to deduct the cost, isn't it?
Yes, sir.
This is the right way to calculate the expected value, isn't it?
Yep.
Okay? But your problem is like you kind of like deduct the $30 two times, right? You deduct the $30 here, and then you deduct the $30 here.
No, Professor. What we did is we add the probability to lose.
You add the probability to lose.
Right. So what we did essentially is 0.476 times
But
bracket.
when you lose, you will get nothing, isn't it? Right? If you want to calculate the probability of to lose, right? You actually have 0.524, right? Chance to win nothing at all, right?
Oh, we.
But this term is not important, isn't it? Because it's go to zero already.
Oh, Professor, what we did is that we times -30 because we thought that if we lose, then we lose 30 bucks.
Oh no, you don't need to do that, right?
Okay.
You mean that you are doing this, right?
Right.
You don't need to do that.
Oh.
Because when you lose, you don't need to pay the $30 again, right?
Oh, right.
You already paid the $30. Isn't it? Right? So you don't really need this term at all, right? Because it times zero, so it's like it automatically disappear, right? Isn't it? Right? So what is the expected value? Anyone? This is not difficult, right? It's simply equal to what? Which is how many?
17.6.
Yeah. This is the net expected value, isn't it?
Yes, it is.
Right? Anyone agree with this? Okay. See, the cost is, you always need to pay the cost, right? So there's no probability, right? Okay. And you have a chance to win is like 0.76, right? You do have a chance to lose, but that when you lose, you get nothing, right? You don't really have a penalty of minus $30 when you lose. Okay. So the correct answer for the correct answer for this scenario is what? You have like, you want to join the game, right? And you want to set the period in from 4.9 to from 4.9 to 3.9, right? This 1 minute of time. Okay. When you choose that, you actually have 47.6% of chance to win $100, right? Okay? But you need to pay $30, isn't it? Right? So the net profit would be, net expected profit would be like 17.6, right? So this is the net expected profit if you join the game and select the period of 3.9 to 4.9 minutes, right? Any problem? Okay. So this is the way that we use the model to help us make business decision. Right? You have a model, and then you can use the model to decide whether you want to join the game. And when you join the game, you want to set the period, right? And then with the things, you actually can calculate for every chosen period, you actually can calculate the net expected profit, right? Now, we call it net because we already deduct the cost, right? We call it expected because you will never win $17.6, right? You would either win 70 or lose 30. Isn't it? Right? So you will either win 100 or lose 30. Okay? But according to our model, it gives us the idea of the expected value. If we join this game again and again, and if our model is reliable, right? Then when you like join the game like 100 times, in average, every time you will win like 17.6, right? So if I join the game, because you are running this helicopter company, right? So maybe every month you will have like 1,000 flights. Okay? Then with this expected value, you will actually have a net expected value to win like 17.6 times like 1,000, right? So you will actually have like you have a net profit of this, right? If you have 1,000 fry, and if you have 10,000 fry, you will have an expected value of like this one, isn't it? Okay? See that? So this expected value is that if you only play the game once, right? The uncertainty is still there, but the best thing of statistic is that when you repeat the game like a lot of times, right? The expected value, it would the actual result would be closer and closer to the expected value. Okay, that's the beauty of statistics, right? Let me say that again, right? The beauty of statistics is that if you only play the game once, okay, you will either win 100 or lose 30, okay? But if you play the game many times, right, the actual outcome will become closer and closer to the expected value, isn't it, right? So if you play this game like 10,000 times, the expected value would be like 176,000. Okay? But because you are doing business, right? And the business will repeat the same business logic a lot of times. Okay? So you can reasonably use the expected value as a guide to do your business decision. Okay? And that's the point. Okay? That's the point. Okay? So this is let's take a quick look at the next business scenario, right? This business scenario is easy because you don't need to write program, right? You simply like by using a tool, using this interactive tool, you can do the decision already. But if we change the rule, right? Okay. Right now, we want to bet on $5 on any 10-second period. Okay. For example, like 0 to 10 second, 10 second to 20 second, 20 second, 30 second. Okay. Or you can bet on like 3 minutes to 3 minutes 10 second, 3 minutes 10 second to 3 minutes 20 second, things like that, right? And you can place many bets, right? It means that it's no longer a consecutive 1 minute, right? You can bet on any 10-second period, okay? And the cost to bet on any 1 second, any 10-second period would be $5, right? Original is 60 seconds and $30, right? The price is actually the same. But right now you can bet 10 seconds, right? And you can actually place multiple bets. Okay. So still you will win $100 if the next eruption time fall within the period you would choose. Okay. So this is a little difficult, right? So for the maximum period of expected value, how would you place your bet? And what is the overall expected value of your bet? Okay? It's not that easy if you want to use this thing to like make your prediction, right? Because right now it's you can place bet at every 10-second period, right? Okay. You need to write program to like kind of do the prediction. Okay? So that's what we going to do in next hour. Okay? Let's take a 10 minutes break, and when we are back, we will see how to use program to deal with this more complicated business scenario. Okay, let's take a break, and we'll be back in 10 minutes.